It's the Nobel Prize in Chemistry today, and we've got a story, well, that's full of holes.
We are talking about metal organic frameworks. Of course, we call them MOFs. And these are the most porous materials in the world. So these are things that could be quite small in size, but have so much internal surface area. We're talking like the TARDIS from Doctor Who. It's bigger on the inside.
And let's name the winners then. We've got Susumu Kitagawa, Omar Yaghi, and Richard Robson.
That's right. So the MOF concept came from Robson in the 1980s. He was inspired by diamond crystals, and he made pyramidal shaped modules, and they are connected with metal atoms linked by organic molecules. Then in the early 1990s, Kitagawa came up with MOFs that could be filled with water and not disrupted if they were dried out again. So the key thing here is that not only could you put something inside, you could also get it back out again. And he also realized that MOFs could change shapes depending on whether they had something inside them or not. Then at the same sort of time, Yaghi designed ways to make these MOFs more stable and to make the linkers longer so you could really push this relationship further. So you ended up with something that could have the internal surface area the size of a football field in a gram, something the size of a sugar cube.
Hence the TARDIS analogy then. And if that was kind of how these things began, what are they being used for now?
Well, chemists have come up with hundreds of thousands of versions of these MOFs, and they have potential for any number of things, from pulling carbon from the air to maybe even removing toxic forever chemicals from the water. But although there's a lot of promise, a lot of these are in very preliminary stages.